Alright, let's continue our exploration of derivative shortcut rules with rule number 3, the constant multiple rule. It says that if u is a differentiable function of x, in other words, anytime we have any variable expression that we know how to take the derivative of, and c is a constant, then the derivative of a constant times this differentiable function is the constant times the derivative of the function. And you can read through the proof of that there. That shows that this is true. You can do that at your leisure. Let's look at these examples. So in part A, y is equal to 4x to the third. So if we take the derivative of this, we take the derivative of this, the derivative of 4x to the third is going to be equal to 4 times the derivative of x to the third. And I'm doing some things notationally here that, we're kind of seeing these used pretty much for the first time. I want to talk about briefly the difference between this and this. The pink highlighted notation is dy dx, which means the derivative of y with respect to x. The yellow highlighted version is the derivative with respect to x of something. And it's something that we have not yet taken the derivative of. And when I write this notation like this, d dx of x to the third, that's an indicator to me that I need to take the derivative of what's inside the parentheses. So I need to take the derivative of x to the third here. And so continuing on, dy dx is equal to 4 times the derivative of x to the third, which is 3x squared. And therefore dy dx is 12x squared. Alright, in the second one, I've got y equals 2x to the sixth over 3. Since these are constants, when I take the derivative here, the derivative of this is going to be equal to 2/3 times the derivative of x to the sixth. So this is going to be 2/3 times 6x to the fifth. And then I'm going to go ahead and multiply that out. And that gives me 4x to the fifth. That's the derivative of 2x to the sixth over 3. And there's how the constant multiple rule works. Alright. Our next set of rules, the sum and difference rule. The first part is the sum rule, right here in yellow, and the second part here in green is the difference rule. They're very similar, which is why we talk about both of them simultaneously. The derivative of the sum of two things is equal to the sum of their derivatives, and the derivative of the difference of two things is equal to the difference of their derivatives. This rule enables us to handle any derivative that has multiple terms by taking the derivatives of each individual term and adding them or subtracting them depending on what sign appears between them. The proofs are identical for this except for the sign, so you can see there the proof of the sum rule, and if you take a look through that, make sure you follow that, and if you have any questions about that, let me know. But there's the derivative of the sum rule, and the difference rule is identical except with a different sign. Alright, let's apply the sum and difference rules to this. What this means is that when I take the derivative of y equals 2x to the third minus 5x squared plus 7, dy dx is equal to the derivative of 2x to the third minus the derivative of 5x squared plus the derivative of 7. And so I'm not going to write crazy, all the detailed derivative notation here. Now that we have the constant multiple rule, this is going to be 2 times the derivative of x cubed. The derivative of x cubed is 3x squared. So that's just going to be 6x squared. minus the derivative of 5x squared. That's going to be 5 times the derivative of x squared. The derivative of x squared is 2x to the first, so 5 times 2x is 10x, plus the derivative of 7. 7 is a constant, so the derivative of 7 is 0, so that's just going to disappear. And there's my derivative of my function in part A. Do the same in part B, dy dx, and I'm going to just take each derivative term by term and put the appropriate sign in between them. The derivative of negative x to the fourth is negative 1 times the derivative of x to the fourth, which is negative 4x to the third, plus the derivative of 2x squared, which is going to be 4x, plus the derivative of 5x. We've got a constant multiple 5 times x to the first. The derivative of x to the first is 1x to the 0. X to the 0 is 1. So the derivative of x here is just 1. So 5 times 1 is 5. And the derivative of minus 3 is 0. So we don't have any more terms in our derivative. And there's how we apply the sum and difference rule to taking derivatives. Now examples C and D, we have product laid out here, and we're going to talk in the next video about the product rule and how we can use that to help us find derivatives. But we're going to do these two problems today using the sum and difference rule. In order to do that, we first need to expand these using algebra. So this is going to be y equals 3x to the fourth minus 4x squared plus 15x squared minus 20. So y is equal to 3x to the fourth plus 11x squared minus 20. And now I can take the derivative of those term by term. Derivative of 3x to the fourth is going to be 12x to the third, 3 times the derivative of x to the fourth. The derivative of 11x squared is going to be 22x, and the derivative of minus 20 is going to be 0. And so there's the derivative of my original function that I have there. I'm going to do the same thing in part D, a little bit more elaborate with the expansion, since we've got a binomial times a trinomial. But I'm going to take 2x squared times everything first. That gives me 8x to the fifth plus 4x to the third minus 14x squared. And then I'm going to multiply the minus 5 times everything. I'll combine any like terms and write this in standard form. So I've got y equals 8x to the fifth minus 16x to the third minus 14x squared minus 10x plus 35. And then I'm going to use the sum and difference rule to take the derivative of this term by term. The derivative of 8x to the fifth is 40x to the fourth. Derivative of 16x to the third is 48x to the second. The derivative of 14x squared is 28x. And the derivative of minus 10x is minus 10. And the derivative of 35 is 0. And there's our derivative. Okay? So at this point in time now we have 4 rules that we know how to use. We can take the derivative of any constant. We can take the derivative of any x raised to any integer power, positive integer power. And we can take the derivative of a constant multiple times something. So we incorporate rules 2 and 3 together a lot when we have a constant multiple times x raised to a power. And then we can use the sum and difference rules to take derivatives of things with multiple terms by taking the derivative of each term individually and combining them using the appropriate sign. That's the end of this video. Check in next time. We're going to look at rules number 5 and 6 of our shortcut rules and get a much broader base of things that we can take the derivative of. Alright, that's it for now. Have a great day. See you next time.